What is hardness of water? As per definition, the property of water to form an insoluble curd-like precipitate with soap instead of forming leather or bubble is called water hardness. That means if you are using hard water instead of using soft water in presence of soap to clean your cloth, you will see that the soap is not forming the bubble, the soap is not forming the leather, rather it is forming an insoluble white curd-like precipitate. Then you can realize this water is actually hard water. That is why it says the property of water which forms insoluble curd with soap instead of leather is called hardness of water. There is another alternative definition of hardness of water which says it is a property which is actually soap destroying property of water, which is also 100% true, as your hard water is not allowing the soap to form the leather or bubble, rather your hard water is forming insoluble curd like precipitate with soap, so your soap is not efficiently doing its job. Your soap is not efficiently doing the cleaning. That is why actually your soap is getting destroyed, and that is why it is called the soap destroying property of water. There is another alternative definition which is also 100% true, which says that hardness means dissolved salts of calcium and magnesium. Why it is 100% true? Because the dissolved salts of calcium and magnesium, that can be calcium carbonate, calcium chloride, magnesium sulfate, these dissolved salts of calcium and magnesium actually will not allow the soap to work properly. Because of the dissolved salts of calcium and magnesium, your soap cannot form the leather or bubble. Because of these dissolved salts of calcium and magnesium, your soap will form the curd-like precipitate in presence of hard water. So all the three definitions, again I am telling, the first definition is the property of water to form an insoluble curd with soap is called water hardness. Second definition is the soap destroying property of water is called water hardness. The third definition is presence of dissolved salts of calcium and magnesium is the definition of hardness of water. And all these three definitions are absolutely correct. Because of these dissolved salts of calcium and magnesium, your soap cannot form the leather, rather it will form the insoluble curd, and because of formation of this insoluble curd, actually your soap is getting destroyed. Your hard water is actually not allowing your soap to work properly, rather it is destroying the soap. That is why all these three definitions are scientifically correct. You can either say the hardness is soap destroying property, or you can tell the water which cannot form leather, rather it will form insoluble curd with soap is called water hardness. The third definition can be the water which has dissolved salts of calcium and magnesium is also called hard water. All the three definitions are actually telling you same thing in defined way. So all the three are absolutely correct. Why hard water cannot form leather with soap? Now to understand this fact, why your hard water cannot form leather with soap, why your hard water rather forms a insoluble white curd-like precipitate with soap, first of all you have to understand what is the working mechanism of your soap. Your soap is basically nothing but two part. One is hydrophobic part, another is hydrophilic part. Hydrophobic part is a long hydrocarbon chain which contains only basically carbon and hydrogen. So this part on your left hand side is called hydrophobic hydrocarbon chain, which hates water but it loves the oil because it is hydrophobic part. There is another part which is hydrophilic part, which is the ionic part, which contains the sodium plus and COO minus part. This is the ionic part, which is the polar part, which loves water because it is the hydrophilic part. So basically your soap contains one is hydrophobic part, another is hydrophilic part. And when you are using your soap to clean the cloth, your cloth contains the dirt or grease which all are hydrophobic. This oil or dirt or grease, they all are hydrophobic. As we know that like dissolves like, so the hydrophobic part may interact with the hydrophobic dirt or hydrophobic oil or hydrophobic grease part. On the other side, the hydrophilic part, which is the sodium plus and COO minus, this polar part may interact with your water. So hydrophobic part will interact with your dirt or oil in the cloth, and hydrophilic part will interact with the aqueous part or the water part. That's how basically your soap can take out the dirt or oil from your cloth. Now, the actual sentence which you have to remember, the key sentence in this mechanism is the sodium salt of these long chain fatty acids. These are long chain fatty acid. One is your hydrophobic long hydrocarbon chain, and in this part you have COO minus. These are long chain fatty acids. The sodium salts of long chain fatty acids are water soluble. So it depends. There are some salts which are water soluble. There are some salts which are not water soluble. Fortunately, the sodium or potassium salts of long chain fatty acids are water soluble. That is why in your soap we use sodium or potassium salts of long chain fatty acid. The long chain fatty acid means hydrophobic long chain part interacts with dirt and the ionic polar part interacts with water. Now let's come to our point. What is wrong with hard water? Why it cannot form the leather? Rather, it forms a insoluble white curd-like precipitate. When you are using the sodium salt of long chain fatty acid in presence of hard water, as you know that hard water contains dissolved salts of calcium and magnesium. Basically, this calcium and magnesium cation replace the sodium cation from the structure of your soap. So instead of making sodium salt of long chain fatty acid, now it has been converted into effectively a calcium salt of long chain fatty acid. Now this calcium salt of long chain fatty acid are no longer soluble in water. As it is not soluble in water, so basically your soap cannot work. So the whole point in this question comes from a single concept that the sodium salt of long chain fatty acids are water soluble. When you are using the soap in hard water, your hard water contains calcium and magnesium ions. Those calcium and magnesium ion replaces the sodium ion from the long chain fatty acid salts. So now instead of having your sodium salt of long chain fatty acid, it has been converted into calcium salt of long chain fatty acid or magnesium salt of long chain fatty acid. And the basic difference between sodium salt with your calcium and magnesium salt is sodium salt of long chain fatty acid is water soluble. That is why it was working nicely in a normal water, in a soft water. Once you are putting it into hard water, it has been converted into calcium salt of long chain fatty acid or magnesium salt of long chain fatty acid, which are no longer soluble in water. That is why they form precipitate, which is the actually white color card like precipitate which we were talking about while we told you the definition of hardness. So this card like white precipitate is nothing but the precipitate of calcium salt of long chain fatty acid or magnesium salt of long chain fatty acid. As they are not soluble into water, so effectively they cannot work. Effectively your soap cannot work, and effectively your soap will be getting destroyed. Your soap cannot do the cleaning job properly.